All right, so 3.1 part 2. That's how I keep myself kind of like, you know, organized here. Got it, Jake?
Huh?
See?
Oh, yeah.
That's how I keep myself organized. All right, so I have my graphing calculator out, and I'm going to try and graph this, this function, okay? 6x minus 7. First thing I say to myself is, what should the graph look like? And Hansi's like, bro, it's linear. Largest exponent is 1. So that means it's going to look like a line. Why do I ask this? Well, if I know what it looks like moving into it, then I can see if I make a mistake. Like for the second one over here, that says absolute value. I know it's going to be some type of V shape. It might be a V, could be an upside down V, but it's going to be a V shape. So with this one, it says x equals -3, 0, 3, 6, and 9. And then my equation I'm trying to graph is y equals 6x minus 7. So I can come over here and I can type in 6x minus 7. And I need to get the table. So I'm going to hit the blue button and graph. And it gives me my table. Now, these numbers in the table will correspond to the numbers in x, so -3. Okay, that's going to be -25. 0, well, that's going to be -7. 3 is going to be 11. Now I need 6 and 9, so I'm going to go ahead and I'm going to scroll down. So 6 is going to be 29, and 9 is going to be 47. Now, Hannah's sitting here, and she's like, Harmon, but my graphing calculator ran out of batteries. So what do I do? Well, when your calculator's out of batteries and you don't know how to do it, okay, and you don't know how to do it, this is all you do. Ready? You take it and you are going to plug in the number. So for example, I would do 9 times 6, that's 54, minus 7 is 47. I can do 6 times 6, that's 36, minus 7, that's 29. 3 times 6, that's 18, minus 7 is 11. So I can just do it that way, okay? Sometimes it's a little quicker, sometimes it takes a little longer, okay? In this one, I think it's quicker to do it using the table. The second one, that one's going to be harder using the table, okay? Now I have to graph it, so I'm going to go ahead and I'm going to plot these points. I don't have a ton of points I can plot because like -25 is not going to be on my graph. 47 is not going to be on my graph. So I'm going to go ahead and plot 0, -7, and 3, 11. Okay, I'm going to do my best. I'm going to go ahead and connect those 2 dots, and my line would look something like this. And if you really want to know what it looks like, you can always hit graph. And my graph and that graph look very similar. Now, I need to do this one. Chris. Chris.
Yeah.
Chris, what do those lines mean? There's like straight lines.
Absolute value.
Absolute value. Now, so many of you guys are dependent on your calculator. Do you actually know where to find the absolute value on your calculator? Where is it?
It's, let me see. It's under X. Wait, no.
Yeah, there's not a button for it. It's hidden. I'll show you where it is. When the time it takes me to tell you where it is, you can be done graphing it. So when I'm graphing an absolute value, yes, you can use your calculator. I'll show you that. But it's also important to be able to plug these things in. So absolute value just means take whatever in those bars and make it positive. So I do 2 times -4, that's -8, minus 7, that's -15. So the absolute value of -15 is 15, plus 2 is 17. 0, 2 times 0 is 0, minus 7 is -7. Okay, so the absolute value of negative 7 is 7, plus 2 is 9. 2 times 3 is 6, minus 7 is negative 1. Absolute value of negative 1 is 1, plus 2 is 3. 2 times 5 is 10, minus 7 is 3. Absolute value of 3 is 3, plus 2 is 5. 10, 2 times 5 is 20, minus 7 is 13, plus 2 is 15. So I can go ahead here. I already told you it was absolute value. So Justin, it's supposed to be what type of shape? V. So when I plot these, I better get a V, right? So negative 4 and 17 is going to be way up here. 0 and 9. Okay? 3, 3, 5, 5, 10, 15. That look like a V shape?
Yes.
Yeah. Now, how do I do it on the calculator? Well, to be honest with you, I'm not 100% sure where it is. It might be in math. So let's see if I can find it. So we hit math. Okay, let's go to number. Oh, NUM. What do you think ABS stands for?
Absolute value.
Absolute value. It doesn't stand for like anti-lock brake system. All right. So it's, yeah, ABS on a car. Anti-lock brake system.
That's
Come
what I
on.
thought it meant.
Unreal. Unreal. Kids these days. All right, so I put it in. Notice I got my 2 bars. Some of you guys might just have ABS in there. Now I'm going to go ahead and do 2x minus 7. Now I need to get outside. So I'm going to hit the over button. Notice it's blinking outside. And I click plus 2. So let's go to the table. You can see with the table, 3, 3, 5, 5. 10, 15, they're all there. It's looking like we got this right. 0, 9, and negative 4, 17. If I hit graph, look, it looks like mine, so I'm good to go. Like I said, Jay, would you agree that this problem was probably a little quicker than searching through your calculator? If I didn't tell you where it was, you wouldn't be able to find it, would you? It's kind of, like I said, it's kind of hidden. It's not like a button, okay? So I'll let you guys copy that down. All right, now we got a bunch of problems to do. So, Jake, what's the distance formula?
The distance formula is x. It's x2 minus x1 squared plus y2 minus y1 squared with the
Square root of the whole thing?
Yeah.
Very good. Not a big fan of memorizing formulas. I try to actually not memorizing any formula. Okay? I don't really like it. The only one I like is the Pythagorean theorem. And I know the distance formula and the Pythagorean theorem are very similar. Okay? I told you that yesterday. If you can find the distance between your x's, it's like your a squared. All right? You can find your a squared that way. B squared is like the distance between your y's. Then you just take the square root of it, and your distance is just equal to the square root of c squared. So here, I told you yesterday, what's the first step, Ed? When I see 2 points, I should do what? Starts with L, rhymes with table.
Label.
Label.
Yeah.
So let's label our points. We're going to label them x1, y1, x2, y2. Do you remember step 2, Hannah? Write your equation or formula. Jake told us that. That was d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. It's a formula. It's a big, long one. Okay, I'm going to show you how to use it. And then I'll show you if you can just apply the knowledge you already have, and there's no need to memorize this. Okay? Now, step number 3 was what, Jay? Substitute. So I'm going to go ahead and I'm going to write d equals the square root of x2 was -3 minus x1 was 9 plus y2 was 7 minus 3 squared. So the first one was -3 minus 9 because it's x2 minus x1. Okay, so it's -3 minus 9. And then I have y1 as being 3. Okay. Now, here, step 4 was what, Leah? Remember? Yeah, we're going to solve and simplify here. So I get d equals the square root, -3 minus 9, that's -12 squared, plus 7 minus 3 is 4, so we have 4 squared. So d equals the square root, -12 squared is 144, 4 squared is 16. So I get d equals the square root of 160, which a little closer to 169. So I'm going to say it's about 12.65. That's my guess.
How do you do that? How do you do that?
No, it's 12.65.
That's why it's
Is it? Yeah, buddy. How?
Yeah.
144, 169. Those are my two perfect squares, right? 144 is 12 squared. 169 is 13 squared. So I know 160 is between 144 and 169. It's obviously closer to 169. It's a little over halfway, right? So I think like 144, 169, halfway would be like what, 57-ish, right? So it's a little over halfway, so a little bit more than 12.5. So I say 12.6, and then I pick 5 because the most I could be off would be like, 0.3 type of deal. So just pick a number in the middle. Sometimes you get lucky. Yeah. So I get 12.65. And that's the distance. Okay, so that's using the distance formula. Okay. And now that you all got that copied down, this is the way I kind of think about it in my head. Okay. So you don't need to copy this down, just kind of watch and listen. All right. I think to myself, I have a coordinate plane here. -3, 7 is like up here, right? And 9, 3 is like here. Okay. So I think to myself, it's kind of like a triangle. And I'm after that piece right there. All right, you guys see where I'm going with this? Now, this piece, the dotted line going up and down, is the difference between 7 and 3. That's 4. You can count the blocks, right? Hello, Steve.
What's up? Yeah.
Now, the difference between the bottom is -3 and 9. That's 12. So now I have a squared plus b squared equals c squared. A, I'm just going to call 4. B, I'm going to call it 12. And c is what I'm looking for. So that I can just do that. No. Notice I'm just applying what I already knew. Distance formula is, I guess, useful, but it's just the Pythagorean theorem. Now, are these points collinear? Well, collinear means in a line, right? What's up?
It's like which one's easier between?
Depends on which way your brain works. I'm a little kind of like, I guess, like a minimalist. I don't like memorizing formula after formula after formula after formula. It's not the way my brain works. The way my brain works is I see something, I'm like, I already know how to do that. Why do I need to memorize a distance formula when I can just use the Pythagorean theorem? Okay, it's like tomato, tomato. It's all the same thing. Okay, now your brain might be like, just tell me the formula and I'm going to apply it every time. Okay, and that's perfectly fine. Right, but I look at it as like it's all the same thing. So here, are these points collinear? Collinear means together in a line. I know, right, Hansi, I know two things. If they're in a straight line, they must have the same slope. Okay? So watch what I do with these problems. I think to myself, okay, 1, 4, and 4, -2. Let me find the slope. So the slope is the difference between your y's, right? So -2 minus 4 is -6. 4 minus 1 is 3. My slope is -2. Agreed? Agreed? Okay, got that? Now, I need to take two other points. So I'm going to use this middle point. It's kind of like the bridge between the two sides. Okay, and 2, 1. Let me find the slope between these points. So 1 minus -2, that's going to be 3. 2 minus 4 is -2. Huh, look at that. I can stop, right?
No.
Why can I stop? Because they don't have the same slope, Hansi. How can they be on the same line if they don't have the same slope? I'm done. It's impossible. Now, how can I justify this to myself? No artist, all right? No artist, but 1, 4 looks to be about there. That's point 1, 4. 4, -2 looks to be about there. And 2, 1 looks to be about somewhere in there, right? To me, if I'm doing a graph, I can kind of see pretty quickly. And you want to know what's nice? If you have graph paper. How many of you have graph paper? On you? If you have graph paper on you, well, this problem's even easier. Right? You can draw up a quick coordinate plane and plot it out. So this is, no. They're not on the same line. What's up, Jake?
So, like, how do you get the slope again between those two?
y2 minus y1 over x2 minus x1. All right, that's what I do. Find the midpoint. Hey, I'm not I told you I'm not a formula guy, right? So, Nikki, you there, buddy? Classic. Liam, you there?
Yeah, I'm here.
Liam, so the midpoint is what? Give me like a dumb version or like a dumb definition of the midpoint.
It's the middle of a line.
Yeah, or I was even going to go with the point in the middle. Okay. Now, when I think of a midpoint, I kind of think of like football field. Midpoint of football field is the 50-yard line. Why? Because you have 100 yards divided by 2, right? I'm thinking about it this way. Okay. Watch this. What's in the middle of 3 and 4? 3.5. What's in the middle of 7 and 5?
6.
Huh, guess what you just found? The midpoint. Now, it's not always that easy, right? But this is all we're doing. We're simply doing 3 plus 4 divided by 2. 7 plus 5 divided by 2. we're finding the average of my two endpoints. All right, Apple Inc. This is a little outdated. 2006. It's okay. You'll get the point. Apple Inc. had net sales of, I don't even know how to say that number. $8,279 million in 2004. And in 2006, $19,315 million. Use the midpoint formula to estimate the net sales in 2005. Now, why is this a bad model? Can anybody tell me why it's a bad model? No.
That's 15 years old.
No.
It's using thousands and it's already
No.
about millions.
This is why it's a bad model. This is why I like math, okay? Because, again, I think outside the box. Do you think sales are linear?
No.
Especially with Apple in the early 2000s? In early 2000s, your iPhone was like on like iPhone Uno, 1. And what happens with the iPhones? iPhones took off, right? Do you think it was a linear model? No, it was probably more parabolic or exponential, right? Think about it. How many of you guys have iPhones?
I do.
Yeah, like almost the entire class, right? So it's parabolic. And they're using a linear model to compare. But for the sake of the problem, Jake, let's do it. All right. So here, the only thing I want to do is, first off, I want to write them as points. Time typically goes first, so 2004 and 8, 2, 7, 9. Now, am I going to use millions? No. Why? I don't need to. Time's already in millions. So that's 2004. 2006, we're at 19,315. Now, we already know in between 2004 and 2006 is 2005. But how, it's not as easy, right, Justin? Not as easy. All right, now how do I do it? Well, now I got to use my calculator. So what you guys want to do is you want to add 8,279 plus 19,315. You're going to get 14 carry 1, 9, 5, 27, 27, 594.
I got 13,700.
Did you do 8,279 plus 19,315?
27,500.
That number?
They had to divide by 2.
And then you divide by 2.
Yeah.
Okay. And what did you get?
13,797.
And that's in millions. So to estimate the sales, it would be 13,797 million. Okay. Cody, you got this problem. This is right up your alley. Oh, you can't see it? Oh, I got you, Hansi. Oh, can we see it now?
No.
Or maybe if you had your notes. I'm so glad this is going on YouTube. A soccer player passes the ball from a point that is 18 yards from the end line. It's just called the 18-yard line. And 12 yards from the sideline. It's like the corner, right? Of the 18, like the 18-yard line. Yeah, no, you know. The pass is received by a teammate who is 42 yards from the same end line and 50 yards from the same sideline, as shown in the figure. Oh, we don't have a figure. How long is the pass? Now, Cody, you're like, does anybody really care about how long the pass was? No, nobody really cares. They're just making up a problem, so you have to solve it. Now, the one thing you're missing here is what, Hannah? What am I missing?
I don't know. Maybe you can try and find
picture. Yeah, you need a picture. So everybody, draw your best soccer pitch.
Let's go.
All right. So I have a soccer pitch, and you're going to want to probably make it a little bigger than that, Jake. It says, soccer player passes the ball from a point that is 18 yards from the end line. We're going to say this is the end line here, 18 yards. Okay? Where do you guys want this side? What side?
Left side.
You want the left side? All right, 18 yards from this side. All right. $12 yards. That way. Watch this. Here's the magic. That point is 18, 12. Like it? Because guess what this is?
Wait, so how did they pass the ball at the same time? No, someone's there.
This is a big coordinate plane. So that's the point right there. 18, 12. It is being passed to a teammate who's 42 yards from the same end line, meaning this. They're 42 yards. And 50 yards. Hi, Kirsten. How are you?
Kirsten.
And 50 yards here.
Hey, wasn't.
No.
I did.
You want me to give it to him?
Yeah.
Scary.
All right, thank you.
My brother.
Yep.
Let's see on Parker.
All right. Hi, Kirsten. So we got the point 42, 50. And I'm looking for that distance. Does that make sense to you, Justin? So I need to find the distance formula. Now, I basically drew the diagram, right? Now, I could do it by memorizing that formula, right? I just thought it's way too much. So here, how far is that? Between these 2 points, how far is that? Where'd you
Wait,
say?
where'd you get the third 30 yards?
No, not this distance.
Yeah, like where'd you get the third 20?
This distance?
Yeah.
No, I'm not. I'm just making the triangle, right?
32 yards.
32?
No, it's 30.
What's 42 minus 18?
Oh my God. Why wouldn't you eat?
How far is
Oh,
this
wait,
distance?
yeah, I didn't look at that. I looked at the 12. Yeah.
24.
So this is going to be 24 yards. How far is this distance?
48 yards.
38 yards. So there's your triangle, and we're after C. So we have a squared plus b squared equals c squared. So a squared is 24. B squared is 38. So c squared is what we're looking for. So now I'm going to do square root. 24 squared is what, 576? 38 squared. Oh. Hold on, don't tell me. 38. No, actually, you have to tell me because we're running out of time. What?
6.30, I'm guessing.
No.
1444.
1444. Running out of time. Where are we going? 1444. And we're going to take the square root of 576 plus that. So 576 plus 1444, 0, carry my 1, 12, carry my 1, 10, carry my 1, 2, 20, 20. Oh, that is so weird.
That makes so much sense.
Square root of 2020. Ugh. Oh. I'm going to say it's like, oof. I don't know, like 47?
You're close.
It's
It's 44.9.
44.9? So C is approximately 44.9 yards. And we would just probably say it's about a 45-yard pass. And that brings us to the 3.2, right?
Yeah.
All right.